Hello students, in this session we will solve multiple choice questions of PUC second year in the form of a model question paper number 3. This is based on NEET and Karnataka Common Entrance Test for the academic year 2021. In this session particularly, we will take up 3 chapters, that is chapter number 8, chapter number 9 and chapter number 10. As you know, the important steps in solving any problem is, first step is to decode the concepts, second step is to identify the formula, and the final step is focus on the question requirements in the question. Let us solve it. Let us recapitulate important formulae that have been used in this section, that is chapter 8 on electromagnetic waves. We know there are 4 laws. Gauss law for electricity, and its relationship is given by E dot dA is equal to Q into Q enclosed, charge enclosed divided by epsilon naught. This is linking electric flux to electric charge. That is Gauss law. Gauss second law is for magnetism. This links magnetic flux to enclosed magnetic charge. Therefore, third Faraday's law is EDS equals minus of d phi by dt. This is induced if electric field is linked to changing. D phi by dt means changing flux. This is changing flux. And fourth one, Ampere's Maxwell law. It is a modified Ampere's law. Modified Ampere's law, and fourth one is also called Ampere-Maxwell law. It is added. So B dot, that is linking the magnetic field to changing electric field and to current. Therefore, B dot ds is equal to mu naught epsilon naught into d phi by dt plus mu naught into I enclosed. That is, it is adding a conduction current. So original Ampere law, which was not meeting some of the requirements, so it is integral B dot ds is equal to mu naught enclosed. This was later modified. This law, Ampere law, was modified by Ampere-Maxwell's law. This is the final law. So the mathematical expression of electromagnetic wave is given by Ey into sine 2 pi into x by lambda minus t, small t by capital T in the J. So this is the, you see, this is the electric field and its equation is given here. You see, this is the equation for this electric field. And Bz is equal to B naught into sine of 2 pi into x by lambda minus small t by capital T into K. J and K are unit vectors in that particular direction. So magnetic field is here. The blue line is magnetic field. And this is the direct velocity of electromagnetic waves in free space. V is equal to C equals 1 over square root of epsilon naught mu naught. That is given by 3 into 10 to the power of 8 meters per second. Velocity of electromagnetic wave in a medium equals V is equal to 1 over square root of mu epsilon that is equal to C over square root of mu r k. With this we conclude this part of discussions on electromagnetic waves. Thank you. These different types of electromagnetic waves in the EM spectrum and their properties like wavelength, frequency, uses, production and detection methods are also given in a nutshell. The first wave is radio wave. It has a wavelength of greater than 0.1 meter and its frequency range is 500 kilohertz to 1000 megahertz. There are different wave bands within this group of frequencies, that is 500 kilohertz to 1000 megahertz. These details we will discuss in the communication chapter. The use of radio wave is in radio, TV and mobile phone. It is produced using rapid acceleration and deacceleration of electrons in area, and it is detected by receiving areas. These can be observed very clearly in radio transmitting stations, production in transmitting station and detection in radio receiving stations. The next wave is microwave. Its wavelength is 0.1 meter to 1 millimeter. So, you see here we started with 0.1 meter and we are ending here microwave at 1 mm. Its frequency range is 10 to the power of 9 to 10 to the power of 11 hertz. These are used in radar systems of aircraft navigation, microwave ovens and to detect fast moving items like tennis ball, cricket ball, etc. and automobiles. It is generated using klystron and magnetron. These are the oscillators generating microwave, and it is detected by point contact diodes. Infrared rays. The wavelength of infrared rays ranges from 1 mm to 700 nanometer, millimeter to nanometer. So, it is 10 to the power of frequency range is 10 to the power of 9 to 10 to the power of 11 hertz. We are using infrared in labs, physical therapy, detecting satellites, TV, CD players, remotes, etc., solar water heaters and cookers. These are produced due to vibrations of atoms and molecules. These are detected by thermopiles, bolometer and infrared photographic films. Then next type of electromagnetic wave is light, which we are commonly witnessing. Its wavelength range is 700 nanometer to 400 nanometer and its frequency range is 10 to the power of 11 to 10 to the power of 14 hertz. These uses are visible light, electric bulbs, tube lights and movie screen. Electrons emit light when they fall from one energy level to lower energy level. This we are studying in quantum mechanics and wave theory of optics. These light is, as you know, it is detected by our eyes, photocells and photographic films. Then ultraviolet ray. Ultraviolet ray, the wavelength of ultraviolet rays is 400 nanometer to 1 nanometer and its frequency range is 10 to the power of 14 to 10 to the power of 17 hertz. Ultraviolet rays are used to sterilize surgical instruments, kill germs in water purifiers, that is the water purifiers which we are using at home, in LASIK eye surgery, burglar alarm and to study molecules. These are also produced by inner shell of electrons in moving from one energy level to a lower energy level. And photocells, these are detected by photocells and photographic films. X-rays. The wavelength of X-ray falls between 1 nanometer to 10 to the power of minus 3 nanometer. You please see it is reducing wavelength. We started with 0.1 meter and we are now passing through nanometer 10 to the power of minus 3 nanometers and its frequency range is 10 to the power of 17 into 10 to the power of 2 10 to the power of 18 hertz. X-rays we are normally used in medical appliances to detect fracture in bones, to detect faults in metals, to detect foreign bodies in human beings. Then these are produced X-ray tubes and inertial electrons. That is, inertial electrons also, when they fall from higher level to lower level, they produce X-ray. These are detected by photographic films. We have also seen so many X-ray films when the medical experts use photographic film to detect the condition of our body. This is also Geiger tubes. This is also detected by Geiger tubes and ionization chambers. Finally, we have gamma rays, whose wavelength is less than 10 to the power of -3 nanometer. The frequency is 10 to the power of 18 to 10 to the power of 24 hertz. These gamma rays are used in cancer therapy to preserve food items and to study structure of atoms. This is also produced due to radioactive decay of nucleus. That is, the innermost part of the atom is the nucleus. It is produced due to radioactive decay of nucleus, and it is detected by photographic films, Geiger tubes and ionization chamber. Hence, remember all these frequency ranges, type of electromagnetic waves and wavelength and frequency. You can remember this very easily. Some people have used a simple way of remembering in the order of their wavelength and frequency. They use a sentence within brackets, radio Mirchi, I love you, ex-wife, ex-girlfriend, sorry, not ex-wife, ex-girlfriend. Radio Mirchi, I love you, ex-girlfriend. This is the sentence, and the frequency also, wavelength remembering is also easy. Just write in the center, you remember 700 nanometer to 400, and this 700 you write here, and then the remaining all 1, and here nanometer, millimeter and meter, meter, millimeter and nanometer, all rest are all nanometers. From infrared onwards it is nanometers. 700 here, 700, 1, 1 and 0.1, and here 400, 400, 1, 1 nanometer, 10 to the power of -3 nanometer and 10 to the power of -3 nanometer. Please remember, go through. These are all very simple types of radio wave, and this is very helpful in communication and medical fields. Question number 1. What is the length of signal of frequency 300 megahertz? Your options are 2 meters, 20 meters, 10 meters and 1 meter. Amongst the 4 options given in the question paper, you have to identify the correct answer and mark it in a circle using a black or blue ballpoint pen, which is permitted in the examination. Let us recall the formula. We know wavelength lambda is equal to c by v, where c is the velocity of light and v is the velocity of electromagnetic wave in free air. So, the given is, we know, we have to remember that the velocity of light is 3 into 10 to the power. It is given that the electromagnetic wave signal frequency of electromagnetic wave is 300 megahertz. 300 megahertz means 3 into 10 to the power of 8 meters per second. So, dividing C by V, we get the answer as 1 meter. Here the option is, the given option is D, which is the correct answer. So, you have to answer the question by just encircling the answer with black or blue point pen. Question number 2. If lambda x, lambda m and lambda v represents wavelength of X-rays, that is, lambda x is the wavelength of X-ray, lambda m is the wavelength of microwave, and lambda V is the wavelength of visible ray, then four options are given: A, B, C and D. The options is given in such a way we have to identify the highest wavelength and the next highest and the next highest. So we have to understand and recollect. We know the microwave has the highest wavelength as compared to visible light, and then which has got higher wavelength than the X-ray. So the answer B, lambda m is greater than lambda V, greater than lambda x, is the correct answer. You have to remember. Please revise the table, full table of electromagnetic wave spectrum, wavelength and frequency and their uses. It is given in the beginning of this video. Question number 3. Human body radiates. Four options are there. Option A, microwave. Option B, X-ray. And option C, infrared rays. And option D is gamma rays. So we have to remember the correct answer. The correct answer is option C, that is human body radiates infrared rays. Next question. Electromagnetic waves can be produced by a charge. So we have to know how an electromagnetic wave is produced. Four options are given. Option A is an accelerated charged particle, and B is a charged particles moving with a constant speed. C is at rest. Option D is either at rest or moving with constant velocity. We should know that for an electromagnetic wave can be produced by a moving charge with acceleration. That is, the correct answer is an accelerated charged particle. So, charged particle moving with an acceleration with varying speed produces electromagnetic wave. So, the correct answer is A. Next question. In electromagnetic spectrum, minimum wavelength is of, again, this is also we have to recollect the table of electromagnetic spectrum. So recollecting, the minimum wavelength is of gamma rays. So minimum wavelength, remember here, minimum wavelength corresponding to highest frequency is that of gamma rays. You have to remember this. Next question. Properties of electromagnetic radiations are identified by using. So we have to identify the characteristics of electromagnetic radiation. So the correct answer is, again, once again, this is also you have to remember that the properties of electromagnetic radiations are identified by using frequency and wavelength. Again, you have to remember the spectrum. Electromagnetic spectrum. Question number 7. Light wave constitutes. So four options are there. Option A, mechanical waves. Option B, magnetic waves, which is not true. Option C, electromagnetic waves. And option D, longitudinal waves. So you have to remember that light waves are also electromagnetic waves. So option C is the correct answer. Next question. Which of the following transport by the electromagnetic waves? Okay, here the question is, what are the items which are transported in electromagnetic waves? We have to again understand and recollect that electromagnetic waves, the energy and momentum of the wave is transported by electromagnetic waves. So correct answer is C, that is energy and momentum. Please remember and understand this. So electromagnetic waves transport energy and momentum. Next question. In a plane electromagnetic wave, the electric field oscillates sinusoidally at 2 into 10 to the power of 10 Hertz and its amplitude is 48 volt per meter. The amplitude of the oscillating magnetic field is. Here, this is a numerical problem. 4 options are given. 144 into 10 to the power of 8, 16 into 10 to the power of minus 8 Tesla, 61 into 10 to the power of minus 8 Tesla, and 144 into 10 to the power of minus 8 Tesla. So we have to use and recollect the formula that B naught is equal to E naught divided by C, where B naught is the magnetic field, E naught is electric field, and C is the velocity of light in air or vacuum. So it is given for E is given as 48 volts per meter, and C we know we have to remember the velocity of light as 3 into 10 to the power of 8 meters per second. So that is simplifying, we get 16 into 10 to the power of minus 8 Tesla. Here the answer is given in B. So B, you mark the answer B as the correct answer. Next question. In a plane electromagnetic wave, the relationship between average energy density of electric field UE and the average energy density of magnetic field UB is. So here once again we have to find the relationship and calculate the values. So we have to recollect the formula UE by UB in a plane electromagnetic wave, UE by UB, that is given by substituting E naught, that is the electric field or potential electric field divided by 2 into E square divided by 1 over 2 mu naught B square. Sorry, I will just recall the formula UE by UB is equal to epsilon naught by 2, where epsilon naught is the permittivity, absolute permittivity, divided by 2 into E square is the electric field intensity, divided by 1 over 2 mu naught. So mu naught is the permeability of the medium into B square. So that becomes, simplifying, the formula becomes epsilon naught into mu naught, that is permittivity, absolute permittivity into permeability constant into E by B whole square. But we know epsilon naught mu naught is 1 by C. So 1 by C whole square. And again E by B is also C square. So simplifying, we get UE is equal to UB. So the answer is B. The correct answer is B. We will lock it. Next question. Question number 11. A radio can tune into any station 7.5 MHz to 12 MHz band. The corresponding wavelength band is. Here he has given the frequency range of the radio station. That is a radio. A radio can be tuned to any station lying between 7.5 MHz to 12 MHz band. So we can tune it. So we have to find the wavelength, corresponding wavelength. That is wavelength corresponding to 7.5 MHz and wavelength corresponding to 12 MHz. Now we have to use the formula. That is V1 is equal to given 7.5 MHz and V2 is equal to 12 MHz. Therefore, lambda 1, we know the formula, we have to use
velocity of light divided by the velocity of the electromagnetic wave. The lowest electromagnetic wave speed velocity is 7.5. So it is 3 into 10 to the power of 8 divided by 7.5 into 10 to the power of 6. Simplifying, we get the answer as 40 meters. So lambda 1 corresponding to 7.5 megahertz is 40 meters. Similarly, we have to calculate the wavelength of the highest band frequency, that is for 12 megahertz. That is lambda 2 is equal to C by V2, where V2 is the velocity of the electromagnetic wave at 12 megahertz. Therefore, that is equal to 3 into 10 to the power of 8 divided by 12 into 10 to the power of 6. That is equal to 25 meters. Hence, the wavelength band is 40 meters to 25 meters. Here, the answer is given in table as C. Option C is the correct answer. So, please lock it. Question number 12. Welders wear special goggles or face masks with glass windows to protect their eyes from electromagnetic radiation. We know, we have also seen welders are wearing special goggles or face masks with glass window to protect their eyes. The radiations of the range of their frequencies are, now we have to find the correct, what are those waves which are affecting our eyes during welding. What are the frequencies that the radiations that are generated while welding? So four options are given. We have to choose whether it is a gamma rays which is getting generated during welding process, or X-rays, or ultraviolet radiations and microwave radiations. Which are the radiations which are getting generated during welding? We know the correct answer is C. So you have to remember it. Next question. An energy of 11 electronic volt is required to break a carbon monoxide molecule into carbon and oxygen atom. So 11 electronic volt is required to break the carbon monoxide, that is CO. When we break it, it comes out as carbon and oxygen. Now the question is the minimum frequency of the appropriate electromagnetic radiation to achieve this dissociation lies in. There are four options. A is visible region, B is infrared region, C is ultraviolet region, and D is microwave region. So we have to calculate it and determine which is the region. Either you can remember it or we will understand also. Given E equals 11 electronic volt, that is equal to 11 into electron volt is, we have to convert into volts, we have to multiply by 1.6 into 10 to the power of minus 19 watts. So we get E is equal to H into nu, where nu is the frequency. Therefore, we have to calculate frequency, that is nu. Nu is equal to, rearranging, nu is equal to E by H, that is shifting H to the denominator. Nu is equal to E by H, that is equal to, given E is 11 into 1.6 into 10 to the power of minus 19. That is from this system. Divided by H, we have to remember here Planck's constant. We have to remember, please note. Planck's constant is H equals 6.62 into 10 to the power of minus 34. Simplifying, we get the answer as 2.6 into 10 to the power of 15 Hertz. We also have to remember that this is the frequency range of ultraviolet range. So, this is a bit ticklish and very ticklish problem. Here you have to understand, we have to first convert E into electron volts, and we also to remember the formula E is equal to H nu. and we have to substitute. We have also to remember the final answer, that is the frequency range of ultraviolet rays. So the correct answer is C. Next question. Light with an energy flux of 20 Weber centimeter per centimeter square falls on a non-reflecting surface at normal incidence. If the surface has an area of 30 centimeters square, the total momentum delivered for complete absorption during 30 minutes is. Please read the question once again. Light with an energy flux of 20 Webers per centimeter square falls on a non-reflecting surface at a normal incidence. If the surface has an area of surface is given 30 centimeters square, the total momentum, we have to find the total momentum for complete absorption during 30 minutes. Four options are given, but we have to use the formula. Straight away you have to apply a formula because it is a numerical problem. We have to recall that the total momentum P is equal to U by C, where U is the energy. Therefore, U is given by the formula I, capital I into capital A into small t divided by C, where I is the current, A is the area, and T is the time. So, 20 Webers, it is given I 20 Webers per centimeter, then centimeter square is area is given 30 by 30. This is 30 into 30 is the area, that is A, in 30 minutes. 30 minutes is we have to convert into seconds. That is equal to 60 divided by 3 into 10 to the power of 8. 3 into 10 to the power of 8. Simplifying, we get the answer as 36 into 10 to the power of minus 4 is the answer. So here we are converting into seconds. So the correct answer is B. Question number 15. The electric field intensity produced by radiations coming from 100-watt bulb at a 3-meter distance is E. The electric field intensity produced by the radiations coming from 50-watt bulb at the same distance is. Again we have to find. The options given are E by 2, 2E, E by root 2 and root 2E. So we have to use the formula again same previously which we used previously. E is equal to U divided by A into T, that is equal to P by A. So E is proportional to P. Therefore, for the given area, so we have to compare the electric field intensity of 100-watt bulb and a 50-watt bulb. Therefore, E dash by E is equal to 50-watt bulb and a 100-watt bulb, that is equal to 1 by 2. Therefore, E dash is equal to, simplifying, E dash is equal to E by 2. Therefore, the correct answer is A. Next question. If vector E and vector B represent electric and magnetic field vectors of electromagnetic wave, the direction of propagation of electromagnetic wave is along. We know it is the direction of propagation is perpendicular to both E and B. That is why we are to recollecting the answer. Correct answer is E cross B. That is option D. Please lock it. Next question. Important formulae are given in this slide.
Focal length f is equal to r by 2. Snell's law, sin I by sin r is equal to n2 by n1, where r that is equal to n2 by n1, where n2 1 is the refractive index of the medium. Refraction in multimedia, it is given by n21 is equal to 1 over n12 or n32 is equal to n31 into n12. Refractive index of medium n is equal to velocity or speed of light in vacuum divided by speed of light in a medium, that is given by the relationship sin I by sin r. Serial 5. If the objective of the medium of refractive index is n is equal to real depth by apparent depth, that is equal to t by t apparent, or apparent shift x is given by x is equal to t minus t by n equals t into 1 minus 1 over n. The serial 6. The critical angle for total internal reflection is given by sin c is equal to 1 over refractive index from rarer medium to denser medium, that is equal to 1 by n, that is from denser medium to rarer medium. Question number 7. Refraction at spherical convex surface V is given by image distance. V is the image distance, U is the object distance. It is given by the relationship N2 divided by V, where V is the image distance, N2 is the refractive index of medium 2, minus N1 by U, where U is the object distance and N1 is the refractive index of the rarer medium. That is also given by the formula N2 minus N1 divided by R. Serial number 8. Lens formula is 1 by F is equal to 1 over V minus 1 U. Using this formula, you answer all objective type of questions. For combination of n number of lenses, 1 over f1 plus 1 over f2 is equal to 1 over f, or that can also be written as if there are more than two lenses, 1 over f is equal to 1 over f1 plus 1 over f2 plus etc plus 1 over fn. Linear magnification is given by m is equal to image distance over the object distance, that is equal to v by u. Question number 11. Lens maker's formula is given by 1 over f is equal to 1 over v minus 1 over u. That is also given by 1 over f equals refractive index from glass to air or air to glass minus 1 into 1 over r1 minus 1 over r2. That can be simplified as 1 over f into n minus 1 into big bracket 1 over r1 minus 1 over r2. We will continue with the important formulae because there are large number of formulae in this section. Power of lens P is given by P is equal to 1 over F, where P is in diopter and F is 1 meter. P is also given by, for combination of lenses, P1 plus P2. And when there is a separation between two lenses by a distance d, power P is given by P is equal to P1 plus P2 minus d into P1 P2. This also you remember if they give the separation as d. Next formula is focal length of lens in liquid is F1 is equal to refractive index of glass minus 1 divided by whole thing divided by refractive index of glass with respect to n1 minus 1 into Fa, where Fa is the focal length of the lens in air. Refraction through a prism is given by R1 plus R2, where angle R1 and R2 are the refracted angles, is equal to A, angle A. That is also given by I plus E is equal to A plus delta,
where A is the angle of prism and delta is the angle of deviation. For minimum deviation, I is equal to E is equal to I and R1 plus R2 is equal to R. Therefore, delta M is given by 2I minus A. Refractive index of a material of a prism. N is equal to sine of A plus delta M by 2 whole thing divided by sine A by 2. For small angle of prism, delta M is equal to N minus 1 into A. Angle of dispersion. Therefore, that is given by delta V, that is for violet color minus delta R. In VIBGYOR, delta V minus delta R, that is dispersive power, is also given by omega. That is omega equals delta V minus delta R divided by delta V. That is equal to NV minus NR divided by NY minus 1, where NV is the refractive index for violet color and NR is the refractive index of red color divided by NY yellow color minus 1. Simple magnifying powers of simple microscope. It is given by M is equal to 1 plus D by F. See, these formulas you have to remember and answer all the objective type of questions. That is, this formula holds good if the image is at a distance capital D. If the final image is at infinity, it is M is equal to D by F. Compound microscope. Capital M is given by MO into ME. That is, MO is the magnification of objective and ME is objective of the eyepiece. This is given by the formula M is equal to minus of L over F naught into open the floor bracket 1 plus D by F naught. This formula holds good when the final image is at a distance D. If the final image is at infinity, the formula gets simplified as M is equal to minus L by F naught into D by F naught. Astronomical telescope. The formula when the final image is at a distance D, M is equal to minus F naught over Fe into 1 plus Fe by D. And length L is equal to F naught plus UE. F naught is the focal length of objective and U is the object distance. When the image is formed at infinity, in case of astronomical telescope, M is equal to minus F naught by Fe and length is given by Fo plus Fe. Resolving power of microscopes and telescope. Resolving power. In case of a microscope, resolving power is given by Rp is equal to 1 over D. That is equal to 2n sin theta by lambda. The next case is resolving power of a telescope. In this case, M is equal to 1 over D theta. See here, the difference microscope is 1 by D and telescope is 1 by D theta. That is given by A divided by 1.22 lambda. Question number 17. An equiconvex lens of focal length 15 cm is cut into two halves as shown in the figure. This is the figure. This is the principal axis and this is the perpendicular axis. So it is cut into two halves. This is one half here and one half. Find the focal length of each part. So we have to understand this problem. This equiconvex lens is cut into two pieces and given F is focal length is 15 cm. We have to remember that focal length of each part is 2F. Therefore, it will be 2 into 15, that is equal to 30 centimeter. The correct answer is C. So, you please lock the answer option C. Next question. How does the focal length of convex lens changes if monochromatic red light is used instead of violet light? So, we have to understand how the focal length of a convex lens changes if the monochromatic red light is used instead of violet light. The correct answer is focal length is increased when red light is used. Question number 19. A glass lens is immersed in water. What will be the effect on the power lens? So this also we have to know that when a glass lens is immersed in water, its power will decrease. Next question. How does the magnifying power of a telescope change on increasing the linear diameter of its objective? There are four options. Power increases on increasing the diameter. Power decreases on decreasing the diameter. Power remains constant on increasing the diameter. Power remains constant on increasing the diameter. Power does not depend on diameter. Correct answer is power does not depend on the diameter of a magnifying power of a telescope does not depend on the diameter. Next question. What is the magnification and focal length of a plane mirror? Here again, we have to remember that the magnification and focal length of a plane mirror is magnification is +1 and focal length is infinity. So, you please lock option A. Question number 22. An object approaches a convergent lens from the left of the lens with a uniform speed of 5 meters per second and stops at the focus. The image. We have four options. Option A is the image moves away from the lens with an uniform speed of 5 meters per second. Option B is moves away from the lens with an uniform acceleration. And option C is the image moves away from the lens with a non-uniform acceleration. And the final option is option D is the image moves towards the lens with a non-uniform acceleration. So we have to select the correct answer. The correct answer is the image moves away from the lens with a non-uniform acceleration. So please lock option C. This also you have to understand and apply. Next question. An astronomical telescope has large aperture. Four options are given. Why do we have a large aperture? Whether it is to increase the span of observation, or have low dispersion, or reduce spherical aberration, or to have high resolution. So four options are A, B, C and D. The correct answer we have to remember that it is for having a high resolution. Next question. Question number 24. The optical density of a turpentine is higher than that of water, while its mass density is lower. So, it is given that the turpentine used in this problem has a optical density higher than water and its mass density is lower. Figure shows a layer of turpentine floating over water in the container. So please see the figure here. This is a container having water at the bottom. Above that turpentine, above that air. So there are three mediums. One is air, second is turpentine, and at the bottom is water. And now he has given for which one of the four rays incident on turpentine the path shown is correct. So there are four options are given. Option 1 is here, ray 1. It has shown the waveform here. The ray path is shown like this. It comes here, and again it bends. Twice it bends towards the normal. Here option 2 is it falls and it moves, bends towards the normal, and then it moves away. Similarly, option 3 and option 4 are given. Now we have to analyze all the four rays. So ray 2 undergoes refraction, that is from rarer to a denser, that is lighter medium to a denser medium, and it bends towards the normal, that is it is moving, the normal is here and it moves towards the normal. And then again it moves from a denser medium to the rarer medium. See, water is rarer medium as compared to turpentine. So the ray bends away from the normal. So path 2 is correct. Here option B is correct. So let us mark option B, that is ray 2 is correct answer, and lock it. So lock the option B. Next question. Optical fibers are based on the phenomenon of option A reflection, option B refraction, option C dispersion, and option D is total internal reflection. You have to remember. Please spend a minute and recollect and recall how the optical fibers work. So our correct answer is optical fibers are based on the phenomenon of total internal reflection. Let us lock option D. Next question. The characteristic feature of light which remains unaffected on refraction is options. Four options are given. Speed, frequency, wavelength. Option A is speed, option B is frequency, option C is wavelength, and option D is velocity of light. So you have to identify the characteristic feature which remains unaffected on refraction. So the correct answer is frequency. Frequency remains same. Frequency does not change when a ray of light undergoes refraction. You have to remember this. Next question. A ray of light incident at an angle theta on a refracting face of prism emerges from the other face normally. If the angle of prism is 5 degrees and the prism is made of a material of refractive index 1.5, the angle of incidence is. Once again, this is a numerical problem. Four options are given. Option A 7.5 degrees, the angle of incidence is 7.5 degrees. Angle B is 5 degrees. Angle C is 15 degrees. And option D is 2.5 degrees. Now we have to analyze this numerical problem. So ray emerges from the other surface of the prism normally. So you please draw the diagram of a prism and mark its incident ray and emergent rays. Because of lack of space, I have not shown the diagram. You please open your book and go through it. Therefore, the angle of incidence at the second phase r dash equals 0. Therefore, now r plus r dash equals a, that is angle of prism. Therefore, r is equal to a minus r dash. That is, a is given as angle of prism, a is given as 5 degrees. Please note here, you can write down a is 5 degrees given. So therefore 5 degrees minus r dash, because at the second phase is 0. Therefore a minus r dash is 5 degrees. Using Snell's law, you have to remember Snell's law also, which states refractive index mu is equal to sine of angle of incidence to sine of angle of refraction. Therefore mu is equal to sin I by sin r. So therefore sin I is equal to mu into sin r. That is equal to 1.5 into sin of r is sin of 5 degrees. So you have to also find out and note down the sin of angle 5 degrees. The answer sin I will be equal to 0.131. So therefore again theta is equal to I is equal to sin inverse we have to take. Sin inverse of 0.131, that is equal to 7.5 degrees. So the correct answer is 7.5 degrees. Here you have to remember many things. In this problem, you have to remember that r plus r dash is equal to a. That is equal to r, that is r is equal to a minus r dash, and given a is 5 degrees, and you also should know that r dash is 0. And you are also to remember Snell's law, mu is equal to sin I by sin r. Or you have to find out the sin I. And mu also is given in the problem 1.5 into sine of 5 degrees. That is equal to 0.131. Therefore, theta, you have to again find out sine. You have to remember, you have to find sine of 5 degrees as, you have to know the value of sine 5 degrees from the book, and therefore I is also, you have to also know sine inverse of 0.131, that is equal to 7.5 degrees. This is the correct answer. Let us lock it. Next question. A passenger in an aeroplane shall, 4 options, never see a rainbow. Option B, may see a primary or a secondary rainbow as concentric circles. Option C, may see a primary or secondary rainbow as concentric arcs and shall never see a secondary rainbow. The correct answer is a passenger in aeroplane may see a primary and a secondary rainbow as concentric circles. Okay, you have to log this option B. You have to understand and log it. Next question. An air bubble in a jar of water shines brightly is an example of option A, dispersion, total internal reflection, option C, refraction, option D, none of the above. So you have to examine and understand the phenomena of shining of air bubble in a jar of water. It is an example of total internal reflection. Please lock option B. Option B is the correct answer. Next question. The line A and B in the ray diagram of figure represents. See, this is line AB. This is the line AB. It represents option A, converging convex, diverging concave, parallel or plane, lateral shift or converging. We have to identify the correct answer. See, it is a virtual image and the correct answer is diverging concave. This will be a diverging concave. Next question. In the minimum deviation position, the refracted ray in the prism is, you have to, four options are given. So, the refracted ray in a minimum deviation position, option A is parallel to the base of prism, option B is apparent depth, option C is real depth, and D is critical angle. So, there are four options given. You have to recollect. In the prism, the refracted ray in the minimum deviation position is parallel to the base of prism. Please lock it. Please lock option A. Question number 32. A diopter is the unit of measurement of optical power of a lens and is equal to. So we should know what is a diopter. There are four options. Option A is focal length in meters. Option B is reciprocal of focal length or focal length in feet. And option D is none of the above, a diopter. So, we know that diopter is the reciprocal of the focal length. So, it is 1 by F, that is F in meters. So, option B is the correct answer. So, you have to remember the definition of a diopter. A diopter is a reciprocal of focal length in meters. So, please lock option B. Next question. When diameter of objective of an astronomical telescope is doubled, its limit of resolution is. See what has happened here. Diameter of the objective of an astronomical telescope. Please underline astronomical telescope. So what happens when objective of the astronomical telescope is doubled? What happens? So we have to understand and remember, if we increase the objective's diameter, double it, then its limit of resolution is halved. That is the correct answer. Question number 34. A short pulse of white light incident from air to glass slab at normal incidence is incident at, I will read the question once again. 34. Question number 34. A short pulse of white light incident from air to glass at normal incidence. After traveling through the slab, the first color to emerge is. We have to know what happens when a white light incident from air to glass, and after coming out of the glass, what will be its color. We should know that it is the first color to emerge is red. So you also have to remember that. Question number 35. Two lenses of focal length 20 centimeter and 40 centimeters are held in contact. If the object lies at infinity, image formed by the lens of combination will be. So, two focal lengths are given. One is 20 centimeter and the second one is minus 40 centimeter. So, the object lights is infinity. They are held, these two lenses are held in contact, and we have to find the final focal length. So, we have to apply and remember the formula. Here it is given 1 by F is equal to 1 by F1 plus 1 by F2. So 1 by F1 is 1 by 20 plus 1 by F2. F2 is minus 40. 1 by minus 40. It is shown here. So 1 by 20 plus 1 by minus 40, that becomes here minus, it becomes, this sign becomes minus. Simplifying, taking 40 as the LCM, we get 2 minus 1. 2 minus 1 is 1 divided by 40. Therefore, inverting, we get F is equal to 40 centimeters. So now we here in the option A is infinity, B is 20, option C is 40. We will lock option C. Next question. Resolving power of a compound microscope is. So here resolving power of compound microscope is. So first is we have to find the resolving power and of a compound microscope. We have to remember the formula. The formula is given in the beginning of this chapter and you have to recollect those formulae for compound microscope. Please remember some of the topics in this uh, academic year have been deleted. I think resolving power of compound microscope is also not there, but anyway, it may help you in answering the questions of NEET examination. The correct option is 1 by d is equal to 2 mu into sine theta by lambda. You have to remember resolving power of compound microscope. Next question.
In this slide, we have given a number of formulae associated with wave optics. The main division is between interference of light and diffraction of light. There are about 9 formulae in interference of light and about 3 in diffraction. Please write down very clearly. These are very important formulae which will clearly explain different phenomena and different concepts of wave optics. Number 1. Interference of light. The resultant intensity I is given by I is equal to 4 I naught into cos square phi by 2, where phi is the initial phase difference between the waves and I naught is the intensity of both waves. Resultant intensity at a point in a region of superposition. So there are two waves with I1 intensity or A1 whose amplitude is A1. A1 and A2 are two amplitudes of waves 1 and 2 respectively. Therefore, I is given by A1 square plus A2 square plus 2A1 A2 into cos phi, where phi is the phase difference. It is also given by I1 plus I2 plus 2 into square root of I1 I2 cos phi. Please note the difference. Here it is in terms of amplitude. The second equation is in terms of intensity. Formula 3. The condition for maxima in interference. Phi should be 2n pi, where n is equal to 0, 1, 2, 3. And the path difference delta is equal to n lambda. Condition for minima. The phase difference should be phi is equal to 2n minus 1 into pi. Please note the difference in phase between maxima, where it is 2n pi, and 2n minus pi for minima. And delta is also 2n minus 1 into lambda by 2. Fringe width beta. Beta is equal to capital D into lambda divided by D, where capital D is the distance between slits and the screen and small d is the separation between slits, two slits, and lambda is the wavelength. The angular fringe width beta t, so beta suffix theta equals beta suffix theta is equal to beta by d, that is equal to lambda by d, where lambda is the wavelength of the light used and small d is the separation between the slits. Please clearly see the difference between beta by capital D and lambda by small d. This you please note and repeat the formulae. Number 7. Minimum amplitude A minimum is given by A minimum is equal to within brackets A1 minus A2. Serial number 8. Minimum intensity I minimum. Intensity I minimum is given by I minimum is equal to A1 minus A2 whole square, where A1 and A2 are the amplitudes of wave 1 and wave 2 respectively. Similarly, I minimum can also be written as I minimum is equal to I1 plus I2 minus 2 into square root of I1 I2. Number 9. Position of n maxima. N maxima is given by Yn. Yn equals n into capital D into lambda divided by small d. Similarly, for minima, Yn is given by Yn is equal to n minus half, close the bracket, within brackets, into d lambda by d. I will repeat the formula. Yn is equal to within brackets n minus half, close the bracket, d into lambda by d. Now these 9 or 10 formulae have been given for interference. Now diffraction. Here in diffraction, the first one is position of nth minima. Nth minima is given by d is equal to sine theta, that is equal to n lambda, where d is the width of slit and theta is the angle of diffraction and lambda is the wavelength and n is an integer. Number 2. Linear half width of central maxima. Linear half width, that is equal to y equals capital D into lambda by d. Lambda is the wavelength of the light used. Number 3. Total linear width of central maxima, that is given by B naught. Total linear width is given by B naught or 2y is equal to 2 into capital D into lambda divided by small d. Please repeat all these formulas. These are all very important, and if you practice it, you will clearly know the difference between various parameters, and your concepts and your remembrance of formula will be strengthened. In Young's double slit experiment, the separation between slits is 0.1 mm, that is small d is 0.1 mm. The wavelength of light used is lambda is 600 nanometers. See here the distance d, small d is given in mm and the wavelength is in nanometer and the interference pattern is observed on a screen 1 meter away. So 3 different units of measurement are given. One is mm, second is nanometers, and third one is meter. Find the separation between bright fringes. Here again, this is a numerical problem and you have to remember the formulae. These formulae are given before the beginning of this chapter number 10. Therefore, recall the formula beta. Fringe width beta is equal to the separation. Beta is equal to lambda d, capital D by small d, where d is the distance between the screen and the slit, and small d is the separation between slits.
and lambda is the wavelength. So lambda is 600 nanometers. So 600 into 10 to the power of minus 9. Nano means 10 to the power of minus 9 into 1 meter. We have kept 1 meter as it is, divided by 0.1 mm. So 0.1 into 10 to the power of minus 3. So all the units we have converted into meters, and again we calculate it, simplify it, we get 6 into 10 to the power of minus 3. So minus 3 again resubstituting, the answer is 6 mm. This answer is option C in your question. So let us lock it. Option B, sorry, it is 6 mm is the answer B here. So please lock option B. Next question. In Young's double slit experiment, the distance between two consecutive bright and dark fringes are given by. Here once again you have to remember the formula. Here recalling, the correct formula is beta is equal to lambda into capital D by D. You remember lambda into capital D by D is the correct answer. So you have to remember this formula. Next question. In the Young's double slit experiment, the fringe pattern as seen on the screen is. Here you have to identify and remember the pattern of fringe which is appearing on the screen as seen on the screen is, it is hyperbola. The correct answer is B, option B. So you please recollect the diagram. It is given in the theoretical explanation which of my videos, whose description is given in, whose link is given in the description part of this video. Next question. The light source used in Young's double slit experiment are. So you are also to identify, remember the type of light source which is used in Young's double slit experiment. And if you remember correctly, the option B, option A is incoherent, option B is coherent, and option C is white light, and D is blue, green, red light, which is used as a light source. The light source in Young's double slit experiment is coherent source. So option B is the correct, and you please lock it. Next question. What is the effect of the angular width of interference fringes in Young's double slit experiment when screen is moved nearer to the plane of the slits? So here you please underline effect on angular width. This you please note. He is asking angular width. Okay. And angular width of interference fringes in Young's double slit experiment, and screen is moved nearer to the plane of the slits. So in normal circumstances the distance was capital D. Here the angular width theta does not depend on capital D because the formula is theta is equal to lambda divided by small d. So angular width theta equals lambda wavelength divided by small d. Hence there will be no effect on angular fringe width. So you have to identify the answer in the four option. Option A is increases. Option B is decreases. Option C is constant, and option D is not defined. See, the correct answer is C, because there is no effect on angular fringe width when the screen is moved. So therefore, option C, please lock and option C. Next question. The phase difference between two waves at the place of consecutive interference is given as a multiple of. So please note, read the question once again. The phase difference phi between two waves at a place of constructive interference. Please read, constructive interference is given as a multiple of. Now 4 options are given. A, multiple of pi. B, multiple of 2n minus 1 pi. Option C, even multiple of pi. And option D, odd multiple of pi. Now we have to recall. So the phase difference of two waves are at a place of constructive interference. So remembering, the interference taking place at points of maximum intensity is called constructive interference. This is by description. So for constructive interference, I should be maximum. So therefore, cos phi should be equal to plus 1. Therefore, I max is equal to 4 times I naught, that is phi is equal to 0, 2 pi, etc. up to 10 n pi. Therefore, it should be even. See 0, 2. So it should be even multiple of pi. So option C is the correct answer. Please go through the theory part also. Open your book and go through the theory part. Next question. The path difference between two waves at a place of destructive interference is given by, see here, path difference. In the previous example was phase difference. Previous question was phase difference. In question number 43, it is path difference between two waves at the place of destructive interference. Please note here in question number 43, it is path difference and destructive interference. Whereas in the previous question, that is question number 42, it was phase difference and constructive interference. So you have to know clearly the difference between the two. 4 options are given. Here it is multiple of lambda. The question options are given in multiples of wavelength. Therefore, A is multiple of lambda, option B is multiple of half lambda, and option C is even multiple of half lambda, and option D is odd multiple of half lambda, lambda by 2. Half lambda means lambda by 2. So let us understand. The condition we have to recollect, that condition for destructive interference resulting in dark rings or path difference is equal to n plus 1, n plus half lambda. That is, option is odd multiple of lambda by 2. Question number 44. Resolving power of microscope depends upon. So we have to remember here in this question, we have to remember the resolving power of microscope. So options, 4 options are given. Option A, focal length. Option B, wavelength. Option C, diameter. And option D is wavelength, diameter of the lens. So you have to remember the formula of resolving power of a microscope. This formula is also given in the beginning of this chapter. Chapter number 10. So you have to recollect. So resolving power of a microscope is given by equals 1 by D is equal to 2n sin theta by lambda. Hence the answer is D. The correct answer is D because it depends on both wavelength and diameter of the lens. Next question. Bending of light phenomena is shown by. Bending of light is due to what? So we have to remember that and understand. The bending of light is due to diffraction. So option B is the correct answer. Angular width of interference of fringe depends on. Similar question is asked in the previous slide. So you have to remember theta is equal to lambda by d. So it is angular width depends on the wavelength and the slit width of the slit. That is, here small d is the width of the slit, lambda is the wavelength. So theta equals lambda by d. Answer C is the correct answer. Next question. Resolving power of the telescope depends upon. There are four options. Diameter of the circular aperture, focal length, C is the magnification power, and option D is refractive index. In this question, you have to remember the formula of magnification or resolving power of a telescope. Please underline telescope. Resolving power of a telescope. The formula is capital M is equal to 1 over D into theta, that is also given by A over 1.22 into lambda, where lambda is the wavelength for telescope. So the magnification M depends upon the diameter of the circular aperture. Next question. In the phenomena of diffraction of light, when the violet light is used instead of red light, what happens? Happens when we use violet light instead of red light? And we should know that the fringe width decreases. Fringe width decreases if you use red light. If we use violet light instead of red light, please correct, when we use violet light instead of red light. The correct answer is C. Next question. Diffraction aspect is easier to notice in the case of sound waves than in the case of light waves because sound waves, four options are given. Sound waves have longer wavelength. B, sound waves are having shorter wavelength. Because the sound waves are longitudinal waves. Option D, transverse waves. So diffraction is easier to notice in case of sound waves, in case of light waves because of in sound waves than in case of light waves because of sound waves have longer wavelength. So option A is correct answer. You have to remember this. Understand and remember. Sound waves have longer wavelength. Light waves have shorter wavelength. Question number 50. The wavefront due to source situated at the infinity is. Now we have to identify the shape of the wavefront. So what is a wavefront? A wavefront is defined as the continuous locus of all particles, wavelets of a medium, which are vibrating in the same phase. So here, the source is situated at infinity. Therefore, the wavefront will be a plane wave. Please recollect the diagrams which I have explained in the videos given in the link. Next question. Color appears on a thin film of a soap and a soap bubble is due to. So we have to appear on the natural effects of light waves. So it is due to what? Color appears on a thin film of a soap and a soap bubble is due to interference. This is due to the interference phenomena of the color. Now we come to the last question. A dentist uses a small concave mirror of focal length 16 mm to view a cavity in the tooth of a patient by holding a mirror at a distance of 8 mm from the cavity. Here the magnification is, we have to calculate the magnification. So this is a numerical problem where focal length of a concave mirror is given as 16 mm and the cavity and the mirror and the mirror distance is 8 mm from the cavity. So let us calculate first. U is equal to minus 8. That is, mirror is 8 mm. Therefore, U is minus 8 and a concave mirror is minus 16. Therefore, we know the formula, we have to recollect. 1 over V equals, that is, the general formula is 1 over F is equal to 1 over V plus 1 over U. Rearranging, we get 1 over V is equal to 1 over F minus 1 over U. That implies 1 over V is 1 over F is 1 over minus 16 minus of 1 over minus 8. So simplifying, this becomes plus, and 1 over 8 minus 1 over 16, that is equal to 1 by 16. Please simplify this. So minus into minus becomes 1 over 8. 1 over 8 minus 1 over 16, that is equal to, we will get V is equal to 16 mm. So magnification is given by the formula mod of M is equal to V by U. That is equal to V is equal to 16 and U is equal to 8. And we get answer as 2. So we have to lock that. So here you have to remember the mirror formula. Okay. That is 1 by V is 1 over F is equal to 1 over V plus 1 over U. And we have to substitute. You are also required to remember the magnification formula. Mod of M is equal to V by U. That is image distance by object distance. That is equal to 2. So please lock it. With this we come to the conclusion of this part 3 of our videos. Now we will review our answer sheet. So this is the general key answer sheet where you are required to answer all the questions. Column number 1 is a question number. This is a question number and options are given by here A, B, C, D. 4 options given in the question are given here and you have to encircle the correct option. Say for example, for question number 1, the correct option is, your option is D. So you have to mark the circle with blue or black ballpoint ink here. So this will be recorded as your options. Okay, correct answer you have to mark. This is the question number and these are the 4 options. So you have to mark again the correct answer. So all the 52 questions discussed in this chapter are marked here. Please go through it and revise it. Thank you. So next part we will take up the chapter number 11, 12, 13 and 14. Okay. Till then you please work hard, practice it. Practice the question and understand. Thank you very much.